Hello and welcome back to Compiler Programming. Today, I think it's time we start thinking about the syntax. And as a first step, I would like to discuss in general kind of what types of syntax are there in programming languages that are more or less widely popular. So you can have several options, and I will just use this C file to write them out. I will not save this, but just so we have something in front of our eyes. So the first category is something like, it's usually called C-like syntax. So as we are writing in C, it's pretty easy to imagine what it looks like. And I don't think I need to spend too much time on discussing this. Apart from just saying, yeah, I mean, it's exactly this, right? You have some kind of blocks that are wrapped in curly braces, and then you have control structures and operators and stuff. So like it's pretty straightforward, and if you've been following this series, and you're pretty used to this. But let's just write out something like, just for each of these, write out something like what the function would be defined as, or something like this. So we say, I don't know, something like function foo is this. We would say that we have I don't know, number is S32 number, and different languages do it differently, right? In C, you would put the return type over here. In Rust or in Go, I believe you would like just say that it returns S32. Personally, I like this version more than the other one. And also, like different languages put the type in different positions here. So like C obviously does this, but then in Go, you would put, I believe, it like so. Not sure in Rust or something like this, or TypeScript also does this stuff. So in general, I don't think it matters much where you put this, but this is what people like to argue about. So I guess it does matter from the marketing standpoint. And I think the whole syntax discussion has kind of two dimensions to it. One, so why do we care about syntax? Let's just have this list, right? First, it needs to tell us, like, it needs to express the semantics of the language. And this is the only real requirement. Basically, we are just saying, okay, whatever we say the language should do, it should be, I guess, easily and straightforwardly expressible with the syntax that we choose. The other two topics are a bit more subtle. The second one, I'd say, is, let's just call it marketing. In a sense that it is very hard to, for certain guys, developers, it's very hard to sell them a language that looks weird. And also, language sort of shouldn't look weird for the purpose looking weird, unless this is what you're trying to do. So I don't know. It's all about how you want to position and which people you want to appeal to, right? If you want to make a, so let's take Go, for example. Go is specifically targeted at people who were previously writing C, so it looks more or less like C with some cosmetic changes, right? And this is done for the sake of marketing as well, right? If you already know C, you shouldn't be alienated by the syntax of the new language. Whether if you're trying to cater to Ruby audience, then maybe, Go is not so much a good thing, or Python with significant white space, right? So I think if you think about creating language, making it look like some other language is important from the marketing standpoint. And I guess the third one is even more subtle, but in something that is not really possible to easily check or design for. I guess it's this whole phenomenon where that the language changes the thinking or the syntax of the language. And this is also, it also happens in like natural languages, so what people speak, not just programming languages. But I think if you write a lot of C, then you start to think in C. If you write a lot of Ruby, you start to think in Ruby and JavaScript and so on. And so in that sense, it kind of ties back to the previous point about marketing, that if you create a language that looks like other language, but its semantics are completely different, people will be very weirded out and nobody will use it, because it's just like it's this mental conflict where it's sort of doesn't do what you think it does, and people just give up and be frustrated the whole way. So this is one of the reasons why you might change things around. But also, I don't know how to design for this, but it is something to think about when you do this. Anyway, getting back to our stuff. So we have if number is whatever, 42, return 1, or let's say we return bool, return true, and return false. And some languages do differently. Again, you can make a choice. Oh, actually, I don't want braces here, but I want to enforce braces here. I want to enforce semicolons, I want to drop semicolons. So there is a bunch of choices that you can make about all of this. But in general, this is roughly what C-like languages look like. The second option is ML style. And ML does not stand for machine learning. It's the name of the language. Basically, it's what something like Haskell and ML, obviously, Elm languages. So this is where you write essentially mathematical equations in code, and you usually would have automatic carrying and so on and so forth. So our function will look very different. So if I remember correctly, it's the syntax of Haskell. So foo is, let's say it will be int32 to int32 or something like this. And then foo is foo of number is, I think Haskell has if, I'm not entirely certain. Number 32, then true, else false. So this is what it would roughly look like in Haskell. And I guess we should also add a definition of data type. So you would have, I'll limit type def because I think it's completely unnecessary. So you say struct foo, and then you would have, let's just put tagged union, because I think it's a very common pattern and it shows like how enums will look like and how structs will look like. So let's say enum foo type is whatever 1, 2, and then here we would have foo type, and then union of um, that were struct one field, 32 one field, one and two field two, something like this, right? This is what we have for descriptors in a couple of other places. And in Haskell, like if you just wanted to express an enum, like Haskell, these things are exactly the same thing. They're not just merged into one, but you also can just do this one, and they are the same. You would say something like foo is one in 32. I think it's like this, or two. I already forgot the syntax. I haven't written Haskell in a long time. Something like this. But the point is, say data and well, something like this, I believe. But the idea is that like here's your tag that is part of the union, and this is the type inside, and you can have like multiple things here. Whatever, there can be more. And the beauty of this is in the fact that if you just want to specify an enum, you could do like, you don't need to provide the data type, and you can say just A or B, whatever. So you just, if these are called constructors, so you can have just a constructor without any fields, and this is going to be what you would do as an enum. All right, so this is two different approaches to how you can do this. Also in ML style, you don't do so let's just actually do this round positive. So let's write example that's a bit more a bit bigger. If it's more than 0, then return a round of number, otherwise return number. So something like this. We want a function that rounds up positive numbers and leaves negative numbers alone. In here, if number is more than 0, then round number, else number. And here you see that a big distinguishing factor, I think, in ML style languages is that they don't use braces for calls. So you would have just a space, and then everything is an expression. So you don't need to like do return. Return is implicit here. But yeah, this is ML style, and the one that I know the least because I never really wrote anything substantial in this is Lisp style, Lisp syntax, where essentially what you're writing is abstract syntax tree, so like a data structure that is interpreted as code. And I don't even know the syntax correctly, so like whoever knows Lisp, don't throw stuff at me. But the idea is you always start with kind of what you're trying to do. So here would have an operation, so something like you have like this plus 1 2. So they don't have infix operator. Everything is in this form. But yeah, it means that the function would also look something like I don't know, function number, and then I guess goes the body somehow. I'm not sure. I never written a Lisp, so we can actually look it up, the syntax, because Lisp define function, just so that we have something in front of us. And what it looks like. Yeah, so let's just copy paste this stuff into here, and you see how it looks like. It's slightly weird. There's a lot of braces, and as I said, like the operator is always at the very start. It does have some interesting advantages. For example, that you can see that plus here, you can apply plus to more than 2 items, or you can apply plus to 1 item, and everything just works out. So this is kind of nice, but usually not a lot of people both like Lisp and like other languages, or like switch between them a lot, and it is not in a popular variety. I think the most popular Lisp right now is Clojure. So, but yeah, it is a very specific flavor. It has a lot of really cool stuff associated with it, like because this is a tree that you're writing. You could very easily do post-processing or macros on this. So I believe the most advanced macro system that exists right now is in a language called Racket. If you're interested in it, you can check it out. It's pretty crazy what you can do with macros there. And there are a lot of computer science papers that talk about, like, that use Racket for this purpose, because you can implement a lot of things in Java with it. It's pretty cool. But getting back to marketing again, it is really hard to sell Lisp to majority of developers. And myself including, I never really got into it, not because I have some superstitions, but just, I don't know, never worked out somehow. Probably because also there aren't really big projects that are using Lisp. I think Clojure is so far the best at marketing, and Clojure's pitch is that it's good, like it uses Java, JVM, and compatible stuff. But anyhow, I don't think that it will be very hard to convince people to use this. Let's just put it this way. And honestly, the same goes for Haskell style, because as soon as people see this, they're like, I'm not sure I want to do this. Like, why are you putting functional stuff on me? And there are like camps of people that, oh, I want my functional language, I want my imperative stuff, whatever. So this is interesting. So here's a very small overview, and now that we need to at some point decide what this language will look like, it's an interesting choice. You notice that I did not really mention Rust, and Rust is kind of interesting because Rust actually internally is probably closer to Haskell than it is to C, but it does use a C-like syntax. And it is one of those situations where I think it's a bit of a problem, maybe, I don't know. Maybe this was their marketing pitch, that they're like, oh, look, this language actually looks like C, so you can totally use it for system programming, and behind your back we will just implement all of this expression stuff and can linear type inference and so on and so forth. So I think it was a very interesting thing that they did. So what I'm thinking for mass, this programming language, is that I will go for C-like syntax, just because that I think it's, as I said, it will be easier to follow for people. And personally, I don't particularly care about the syntax as long as the language has a sufficient level of macro support, which is something that we will be adding in the future anyway. I don't think that syntax is a deal breaker in any shape or form, and having something C-like is fine. I do want to make certain changes to the syntax, just because I don't think that C1 is particularly nice. So the first thing is we will take, so let's put mass. So first thing is we will take something like this. And I think that Rust does the same stuff, where you can specify tagged unions essentially in language, and I think it's really important. I think in Haskell, in Rust, they are using the enum keyword, and so I said like they just just did that, and maybe this is sort of the same thing as we will do, where you say basically enum A, B in exactly the same way as you did before in C, but then you could say actually A is what? One field, whatever, A, and yeah. Another thing is where do you put the type? And this is a very interesting choice, right? Essentially, whether you put it first or second, you are saying, oh, I want, like, I'm saying that the name of my field is more important, or the type is more important. In something like Haskell, you maybe noticed they don't even have field names for a lot of the stuff, right? You can have records, but it's they're very rarely used, at least right now. So yeah, it's a kind of interesting thing. I think that putting type second is better, personally, but doesn't really matter. So we can say B32, C 32, something like this, right? So this is what I'm thinking about right now. Again, I don't particularly care if it is going to be exactly that way or not. Also, you can always drop the commas. It usually makes the parsing slightly awkward. But in general, I don't think it matters much if you put them in here or not. You usually have to put them between the fields, but again, if you have something like this, then you do not have to have them. So this is my thought about the types. One problem with this stuff means that your tag unions are different from things that only have one item, I guess, but maybe that is fine. So maybe we do still want to have struct, but I'm not sure, because this is kind of slightly strange, where you have two ways to specify exactly the same thing. So I don't know, but we can stick with this for now. And finally, for the functions, what I'm thinking is to go the route of probably Rust mostly, so something like fun. Honestly, I don't care what the keyword is, and but to be consistent, we would put the name on the left side. So it would be something like round positive is a function that has, again, a number that is S32, and it returns a will. So I kind of like this syntax more of what we have here, and I think I also like the version where the braces are mandatory, but the semicolons, the braces, these braces are mandatory, but parentheses here are missing, same as in Go, and I think maybe Rust has it the same way. Semicolons probably also not necessary. And another thing that also happens in Rust and happens in, I want to happen as well, is to remove this return and make if into an expression and make everything into expression, including like block. So if I do like 1 plus 2, I could do something like this. I could do foo s32 equals like so. This should work. And you can do, I don't know, bar is s32, whatever, 42, and then I say bar plus 2, right? And foo will be assigned to 44 in this case. So I think that it is very, very strange that in C blocks don't return the value, especially now that you have now that you have seen what assembly looks like. It makes absolutely no sense that you have statements that do not return the value, because in general case, returning a value just means that you like all assembly instructions, even the ones that target two operands, they use one of them as their result. So no matter what you do, you would have a result, except for the move instruction, I guess. But even as far as move goes, you always have the target operand, and this is what you can return from your stuff. So anyhow, yeah, this is what I'm thinking about right now in terms of syntax. We'll see if this is gonna be like this at all. I will probably dump this into some test file or something like this between the videos, so we can start looking at how we're gonna parse something like that. That will be it for today, and hopefully in the next video we're gonna start working on our tokenizer and parser and all the standard jazz that is required to make a programming language. For now, I thank you very much for watching, and see you then.